Hello, this is Richard Collins, your instructor in ATM101, Weather and Climate of Alaska here at the University of Alaska, Fairbanks. Welcome to Unit 13. In this unit we'll be exploring the planetary circulation. The planetary circulation is also called the global or general circulation. In the investigation this week, you'll be making your last week of weather observations for the semester. The idea here in Unit 13 is to have a set of observations that you can contrast with your observations in Unit 8. They're separated by over a month in time, and it allows you to explore how the weather in different parts of the season is related to the climate in different parts of the year. The reading for this week draws on Chapter 9 of the textbook Weather Studies, and again is called the planetary circulation. The idea here is that we're using the principles of heating, gas behavior and winds that you've studied earlier in the semester to understand what's happening in the atmosphere in the big picture. And the amazing part is that you can understand the general circulation at about the 80% level with the general principles that we have developed over the semester. When we look at the general circulation, we'll see how the general circulation drives the pattern of deserts in the subtropics, 30 degrees north and south are the major desert regions of the Earth, and why we have stormy regions in subpolar latitudes at about 60 degrees north and south. We also see that the general circulation moves with the seasons. It moves north in the northern summer, it moves south in the southern summer. And this question of how the major cyclones and anticyclones move with the general circulation is a huge factor in how weather changes around the planet. And we'll see as we discuss climate later in the semester, the movement of anticyclones and cyclones is a major part of how climate change may manifest itself. That the atmosphere isn't just a bathtub. The atmosphere is a structured set of semi-permanent cyclones and anticyclones that drive regional weather, and if they move, it drives in changes in regional weather in major ways, and this is all highlighted in Chapter 9 of the textbook. Finally, we look at variations in large-scale regional weather systems and regional weather events like El Nino, how those occur on timescales of 10 and 20 years is an active area in atmospheric science research, and also the connections of events like El Nino that have impacts around the world. One thing to take away from this chapter is that a lot of the things we study aren't discovered by scientists studying meteorology. El Nino was known by people in Peru because it caused fisheries to fail. The Pacific Decadal Oscillation was understood by researchers in Washington who were understanding salmon returns in the North Pacific. That these questions are not just meteorological questions of intellectual interest, they're also fundamental questions about fisheries, agriculture, and how we maintain life on Earth as human beings. In the lecture screencast, I highlight what I think is important for the quiz this week. If you have any questions, don't hesitate to contact me or Cameron. Thank you and good luck.